In part 7 of our trigonometric analysis and our review for calculus, we're going to look at graphing each of these functions. Now, I know the next section says solving trigonometric functions, but we need to know a couple things before we look at this section. So save this for when we are in class and we know more about properties of trigonometric functions. For the vast majority of us, we've seen this once or twice, and so when we are sketching trig functions, we have two ones that we need to know what they look like, and that's sine and cosine. So what we are doing is we are looking at the angles as the inputs, and we are graphing the output values. So if you have your unit circle, take a look at it. The period for a standard trigonometric function is 2 pi. If we take half of that, we would get pi. Half of pi is pi over 2, and halfway between pi and 2 pi is 3 pi over 2. In general, we do not graph in degrees. The highest value you can be on the unit circle is 1, and the lowest value you can be is -1. So I'm just going to graph this exact same interval with the amplitudes being the exact same. With sine, when we start at the origin, we look at the y value. So the y value at 0 is 0. The y value at pi over 2 is 1. The y value at pi is 0. The y value at 3 pi over 2 is -1. And the y value at 2 pi is 0. And so we get this sinusoidal function, this wave function, this oscillating function that repeats on and on forever and ever. Likewise, if we were graphing cosine, we are looking at the x values. So if we look at the x value along the unit circle, we see that the x value at 0 degrees or 0 radians is 1. At pi over 2, the x value is 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, we are back to 1. So whereas sine starts at the origin, cosine starts at the amplitude. But otherwise, they are just half a phase different from each other. Now, when we're looking at more complicated functions, we need to be able to determine the period, the phase shift, the amplitude, and the vertical shift. So that's why we use the letters A, B, C, and D. To find the period, and what the period means is the length of a cycle. How long does it take to repeat itself, to go from one upper hump to the next upper hump? So we look at 2 pi over b. We take this value that's inside the parentheses in front of the x term. We are looking at the coefficient. We do 2 pi divided by that value. The amplitude means the height of the wave, which would be the absolute value of a. We don't have negative amplitudes. What negative values do just inverts the graph of the function. If we're looking at the phase shift, we're looking at shifting the graph left or right. And so we look again on the inside and we do -c over b. And then a vertical shift is obviously shifting our graph up or down. And that is just d. We just take the value and that moves our graph up or down. So let's practice one of these. So sketch the graph of this cosine function. So we first look at A is our amplitude. The amplitude is 1. Our B value is 2. So we use the letter capital T for period, and we say 2 pi over B. And so we do 2 pi over 2, which is pi. If we are looking at our phase shift, bonus if you knew that the phase shift, and I always struggle with drawing this, but it is a Greek letter called phi for phase shift, is -c over b. So in this case, our phase shift would be pi over 4 units to the right. And lastly, we look for a number on the outside. Because there's no number on the outside, we see that the vertical shift is 0. So now once we have all of those, my suggestion to you, and this is how I tell all of my classes to graph this, you start at the phase shift. You finish at the phase shift plus the period. So our phase shift in this case is pi over 4. Our period is pi. So pi over 4 plus pi is 5 pi over 4. Now, why we do this is this gives me my 2 endpoints for starting and finishing. How do we find the point in between those two? We take half of that. So you can either add those two values and divide by 2, or halfway between 1 and 5 is 3. So we have 3 pi over 4. Halfway between pi over 4 and 3 pi over 4 is 2 pi over 4, or pi over 2. And halfway between 3 and 5 is 4 pi over 4, which is pi. I mark off my amplitude. We said our amplitude was 1. We are graphing a cosine function. So in this case, it will start at our amplitude. So we are going to start at 1. Then we go to 0. Then we go down. Then we go up. And then we come back up to where we started. And if you get good at this, you start seeing that each one of these is its own curve. And that is how I want you to graph our trigonometric function. Other ways you see trig functions. It will say find given trigonometric functions where I give you this value to draw a triangle, and this portion tells you what quadrant. And that's key. You need both of these to figure out where to draw your picture. So in this case, I will draw an XY coordinate plane. It tells me that it's in the first quadrant because that's where all angles 0 to pi over 2 are. I'm going to mark my base angle to be theta. And now I know sine is opposite over hypotenuse. My middle missing term is 3 squared plus x squared equals 5 squared, or 25 minus 9 is equal to x squared, which is 16. So x is equal to 4. Now once I have that, cosine is just x over r, or adjacent over hypotenuse. So in this case, it would be 4 over 5. And tangent is y over x, or opposite over adjacent. So in this, or sine over cosine, whichever you want to use to find the missing values. We just know that the tangent of the angle would be 3 over 4. The last bit of these notes is just properties that you should have seen. And then we are going to go back in class to solve the other problems that we have yet to see. So complementary angles. Sine and cosine are cofunctions. So if you shift either of these functions by a factor of pi over 2, you get the other function. Likewise, if I have cosine of shifting a cosine function to the right pi over 2, that would yield us a sine function. Sometimes we have to separate out function or trigonometric functions because there is addition on the inside. So we call these the sum and difference formulas. The way I remember this, and I write this plus or minus and plus or minus on the inside, so I don't have to write the formula 4 times. Sine is slow, cosine is quick. So cosine for the sum or difference formula would be cos, cos, sine, sine. Cosine changes. So if we have a plus on the inside, it would be a subtraction sign in between the two. If it's subtraction, it would be addition. Cos A, cos B, minus or plus, sine A, sine B. And note, it's one or the other. We're just combining these two for simplicity's sake. Sine is the slower of the two. So it's sine, cos, cos, sine. Sines stay the same. Cosine changes. So if it's a plus, then it stays a plus. If it's a minus, it stays a minus. We can use those sum or difference formulas to get to our double angle formulas. And if we look at our double angle formulas, we either have sine of 2x, so double our angle, would be 2 sine x cosine x. If we did the double angle formula for cosine, it's one of 3 different options. Now, the easiest one that we can use would be cosine squared minus sine squared. Or we could say this is 2 cosine squared minus 1. Or we could say it's 1 minus 2 sine squared. Each of those are equally valid. The last formula that I want you guys to see before we finish this video are the half angle formulas. These are rarely used, but I do want you to see them. So depending on the value of where our half angle is located, the half angle for cosine is 1 plus cosine x over 2. And the half angle for sine is plus or minus square root of 1 minus cosine x over 2. I will just make a note. For any formula that I ask you to use, I will make sure that I provide it to you in a formula sheet. We have a handful more review, but now we are through the hard part. We are through logs, and we are through trig. We are going to practice this to get good, and then we are finishing up this with inverses, inverse functions, some solving equations, and the difference quotient and graphing piecewise. So if you can do all of that, then the rest of this month will be easy as we slowly get into calculus. See you, Falcons.